Every time you chat with ChatGPT or see AI writing code, behind the magic there's PyTorch, the engine that teaches machine to think. But what if you could build your own LLM from scratch, step by step? That's exactly what this series is about. Everyone uses the LLM, but in this series, we are going to build one from tensors to transformers. We'll go beyond the tutorial and actually make PyTorch speak. I used to think LLM were just too big to understand, just buzzword and black boxes. Then I discovered PyTorch and everything clicked. In this series, I'll show you how it all connects. No bluff, just pure AI engineering. And we are going to together learn all of the fundamental that is required to build scalable machine learning system, and you are going to witness how your understanding changes over the series. To use GPUs, and not everyone will have the access to those machines, so we are going to use the Google Colab for learning all of the PyTorch. And this is free. You can make your account here. How to get the access of GPU? You'll need to click on the runtime, then change runtime type, and then select T4 GPU, then save it. So Google Colab give you generous free tier, and it'll be more sufficient for this tutorial. First thing first, let's install the PyTorch. You can code along with me. So let's do capture, and let's do pip. Let's install. We are going to need transformer, and we'll go with the version 4.4.1. If you don't want to expect any errors, you should also feel free to use same as my versions, so that it's easier to replicate. And let's go for any version higher than 0.27.2. So by default, the Google Colab comes with and PyTorch installed, which is going to be sufficient for us. So now that you have your runtime setup done, you have done your transformers there, and this is also installed. So the first step in the ABC of this series is going to be how can you load a language model into your GPU for faster inference. And note that we are loading model, and we also need to load tokenizer separately, although it's not necessary, but it becomes very useful, you'll see in this series. So from transformers, let's import transformers. Let's import auto model for causal LLM. So first L is small, second is bigger. Auto tokenizer. Yep. And so this is going to import the transformers classes that will be useful for us. Perfect. We are good with it now. Let's load the model. Let's store it in the model variable. Model for causal LLM from pre-trained. Actually, how can I turn this off? I don't want this AI suggestion. Ooh. Tool setting editor. Setting editor. Show context powerful. No, we don't want. Yep, I think now we'll be able to code perfectly. So from pre-trained, still happening. Gate code completion section. Tool setting AI assistance. Editor. I believe now it's stopped. So let's use Microsoft's Phi 3 model, which will be comfortable to load in this 16 GB of VRAM. Microsoft Phi 3/mini/4K instruction. I think it's instruct. We'll check. That's the correct model that I remember. So you should also have your Hugging Face account setup done. There you can search for any model that you like. So ours, this is the model that we are going to do. So let's make sure that you have typed it correctly. You can bring any model of your choice. Now the second argument is important. Where do you want to load this model? And whenever you say I'm writing as CUDA, that means that I want my models weights and biases uh, be be sitting in the GPU RAM. And then there is also it expect us to also tells the data type. So it's because it changes based on which model you are loading. So you can mark this as auto, and it will be auto configured. So trust remote code is true, is false. Yeah, so we don't want that. I believe it's going to load the model. Meanwhile, uh, let's load the tokenizer. Auto tokenizer auto tokenizer dot from pre-trained, and let's use the same model Llama 3. Usually this is for them, you'll have to type the same string, and this is what this is going to do. It's going to load your model and tokenizer, and that's pretty much how you bring your model and tokenizer for you locally. Now what although you can use the model and tokenizer directly, but it's much easier to wrap them into a pipeline object. So where can you find this? So from transformers import pipeline, you can directly bring it, and then let's create a generator pipeline, which is in the pipeline you'll have to specify the sequence and the task. If it's a general task, then there are the handlings are being done at the PyTorch level. Since this is the first tutorial, so we are going to use the inbuilt one. Later on we will be building our own pipelines. So, and then you have to specify which model. So what it is going to do, it is going to make two execution for us. One is generating the tokens and then passing it to the models. Tokenizer, and let's also return full text. So return full text. Let's not return full text, but let's define the max new token to be, let's say, about 700, and let's do sampling. Let's not do it. Yeah, so this is going to be the generator object, and after that, once that is done, we are going to call it. So for that you'll need the prompt, the input, the query for your model. So now let's define the message template for our model, and it's going to be an array. The first is the role is going to be of user, and let's give this as context, as tell me the capital of USA. Let's say if it's able to do it, and then output, let's get generator, and we're going to pass the message inside of it, and then let's print out the output. So output is an array, usually the first value, and let's get the generated text. So because we don't want the other things, so let's run it. So did we not pass? Each tick must have a role and content key. Did I? Oh, sorry, I passed that as the context. It should be content. So it's fine. It's good that errors are coming while we are learning. Will show up. All right, so for this model, I believe that argument is not in use, but that's fine. Maybe that's some other arguments that we need to pass. So there you go. You can see the capital of United States is Washington DC. It's not part of the US. It is a federal district, which means it directly governed by the US Congress. Washington DC was named after George Washington's first president of United States. And let's look at the RAM usage. So the GPU RAM is about 7.3 gigabytes, and it has taken about 40 gigs of disk storage, and system RAM is about 6 GB. So what happens when we ask it to run for long? Write 8,000 word stereo story. Let's see how the GPU, if there's any spike in the usage. I believe it's quite stable. Yeah, so it's done. So nothing, just the system RAM increases a little bit, and it printed something, right, which is not the scope. I mean, what we wanted to learn is like, how can you bring any model from Hugging Face, load it in your environment, and then in the next chapter we are going to learn more complex things. And this is the hello world of this series, you can say. Stay tuned. Thank you for watching.